Hi, my name's John Capobianco, and I'm here really excited to show you the next iteration of the Packet Copilot tool from Selector AI. Now, this has gone through several iterations, and we're going to talk about the timeline. We're going to talk about the new approach, the new architecture, the new tooling, the new visibility, and really this agentic AI approach of using tools and agents and incorporating graph from LangGraph. So we still have some LangChain, and we still have Retrieval-Augmented Generation from the core tool. We'll talk about that more. But we've shifted the approach. We've made the code more modular. We've broken up the pieces. One of the most remarkable things that we're introducing is a REST API. So with the REST API, we can transfer packet captures programmatically now, which opens up the world to automation and to other front ends, and to decoupling the front end from the Retrieval-Augmented Generation, and to incorporate this into Selector's product, hopefully in the roadmap. Very exciting things. So let's take a look at this together. We're going to start with some drawings. Okay, just to bring everyone up to speed, I'm going to draw a quick Excalidraw here. So previously, we sort of had this approach where a person, right, uploaded a PCAP with a prompt. And this was the Retrieval-Augmented Generation with an LLM, a large language model, with embeddings, vectors, in a LangChain with a streamlit front end. Okay, this was the sort of approach that we had. I also added some public IP tools in the form of agents. That was a recent development. A few agentic tools to augment the data if we find public IP addresses in the packet. Now, I'm going to move this over and we're going to take a look at sort of my new approach. So, we're going to not worry about the front end. I'm going to draw a square here. What we now have are a few things here. So this is now a REST API in the form of a LangGraph. All right, so this is a LangGraph running on port 2024. This has /docs. It has threads. And it also provides streams. And it ties into some other tools. So now, what we can do, let me center this up a bit more, is a few things. One, we can do a simple curl. All right, so we can do a curl now. And again, what we are sending is a PCAP and a prompt, the question. Right? Now the PCAP, in this case, is going to be base 64 encoded. So that way I can send it through the API. Now this leads also to me being able to write that streamlit front end. But all the streamlit code has now is the front end to do those things, to send the PCAP and the prompt in, right? Now, some other tools that we can tie into this include the LangSmith. Now, I'm using this for two things. For a tracing capability and for a studio. All right? So, how does this work now? Now that I have this graph, Well, the graph, I'll show you what the graph looks like. But basically this graph, if I blow it up, looks like this. We have an assistant, we have tools, and we have an exit or an end. Now this does imply that there is a start here. So this is the graph. We come in with our prompt, the question from the user, as well as the PCAP data. And it can call tools, tools can respond, and this can happen in a circular motion until we decide to exit and end and return the answer to the user. So what are in these tools, you might ask? Well, the tools include the original RAG solution for the PCAP, right? So this tool is actually called PCAP RAG, so the Retrieval-Augmented Generation, right? It's not an either or with agents and RAG. They can run very happily together. And again, what we have is the tools being able to call PCAP RAG. Now I have too many others maybe to enumerate, right? But what I have is this idea of a public IP. Actually, let me make that a check mark. If a public IP is detected, go ahead and iterate with other tools because it's a public IP, right? So these might be things like ping. If I make that a little bigger. These might be things like ping or curl or dig. We might be able to look up the BGP information from the public IP. We can look up geo information, right? You get the idea. All these tools, given it's a public IP address. So this is the RAG, by the way. We are still doing this approach where we're taking the packet capture data, loading it, transforming it, embedding it, storing it, and retrieving it. So when that question comes in, if I zoom out, from here, from the Streamlit, we hit the graph, graph starts, assistant analyzes the question in the PCAP, or the question, excuse me, I should move this PCAP down here. PCAP. Right, so the questions come in, we've started the graph, the assistant routes to the PCAP RAG, it returns its analysis. If we detect the presence of a public IP, run some other tools, exit the graph with the answer back to the user, right? Or a curl, it's the same thing. Or anything that's coming in through the REST API, right? So we're going to go into the code first. And I have two Docker files here. I have my main Docker file for my graph and all of the tools, utilities that I need, things like that. The T-Shark tool from Wireshark, jQuery, all of the LangChain code. And then my Streamlit, which just brings in requests and Streamlit and starts on its own port. Okay? So in terms of the Docker Compose, we have to bring up the Copilot graph and the Streamlit application. Little startup script to start LangGraph dev on this host with that port number. All right. Now, in terms of the code, you can see all of the tools have their own individual little file, including the PCAP rag file. And then there's the curl file. All of them are prompt driven. All of them are very small, tight little tools. We have our LangGraph, which if I collapse my assistant, is quite simple. The list of tools, the LLM binding the tools, a system prompt, my assistant code, and then the code to build the graph. Very simple and straightforward stuff. My Streamlit app for the front end, which runs separately. So I've started this code up, and you can see that I have my Streamlit app running, and I have my LangGraph running. We can visit the documentation for this here, and this documentation is actually customized for our actual API, right? It shows you exactly what you need to do to start a thread. And by a thread, if I have 3 users here, 1, 2, 3, each of them own in their own web session, they each have their own thread. And the threads can call different tools. It's all fully isolated from each other. There's no overlap, highly secure, and highly efficient with CPU. Because some of our tools like ping might take a long time to come back. Now the other link here takes you to that studio view that we're looking at right now. And you can see we have the start and the end and our assistant, which has access to tools. And that's it. I could feed it a message. The human message and the system message could be the base 64 code. To play with this, I could call a tool and input the JSON data. A whole interactive studio. The other thing I have, and we're going to look at this closer, is my LangSmith tracing. So we're going to filter this on the last hour, and we're going to come back to this. We're going to start a few runs and look at the tracing. Now, you're not going to believe how incredible this all is. So everything's up and running. Before we use the Streamlit app, and before we do anything else, let's do a curl. Okay, so if I do, an LS here, there is a folder or a file called capture.pcap. All right. Now I'm going to go to my README because we have to do 2 things with our curl. We have to post against the threads API to start a thread, and then take that thread and start a running stream of that thread, which is going to have our prompt and our content, the base 64. I'm using base 64. Sorry, a little hiccup there. We're going to grab this without the comments, and we're just going to do this, right? So we need to start a thread. This is how the API works in case you want to automate against it. So we got a thread ID here now. We're going to make a base 64 out of our PCAP. And I have this PCAP locally here. If I do an ls star PCAP, you can see I have this capture here. All right, so we're going to base 64 that capture. And now we're going to start a thread, a streaming thread that has a message with the human input and the system input, which is the base 64 PCAP data. Then we're going to watch for the raw response. Now what I'm going to do is I'm going to have the LangSmith here in the background, and we can watch this thread in action. So we can see here that we have the metadata, attempt 1, and the run ID. the prompt and the base 64 data, some heartbeats. If I refresh this page, we can actually see this run in action. Now, right, it keeps going. And we do have the 192.168.2.61, right? It's right here, the content, right? So from the response, the messages response, we can extract the content here. It appears the provided tool outputs contain limited information, specifically noting the source IP in the packet analysis is 192.168.2.61. This is a private address, therefore I can't do geolocation or whatever. Now if we look here in the trace logs, we can see it took 13 seconds. Human input, system input, and then down here we have the AI answer. Okay? Now, if we go to the assistant all the way through this, we get some trace values here, lots of great information, and now the PCAP RAG tool. So this is the tool, right? Now the tool takes the PCAP state, the user input, and we get the output of the source IP here. We have the conversational retrieval chain, which looks up this data. Right, so here's the document in the vector store. Pretty neat, right? So this is the actual packet that's now been stored in Chroma DB. So we're using the conversational retrieval chain, which uses the LLM, the vector store. We're quickly looking up, is it a public IP? False. So therefore, it's not going to run any of the other tools. And now we get the final answer out to the user, right? So really cool. So we're going to come back to the trace. So that is the curl. And if it can work through curl, then we can write a front end for it, or we could write a Python script against it. So here is the, this might look familiar to you if you've used our Copilot. I can actually show you the live version, but I've tried to make it, and I've added a Google packet. So the Google packet's going to have a public IP address in it. Okay? So here's what we're going to do. We're going to drag and drop the Google PCAP, proceed to chat, and ask it, what can you tell me about this packet capture? Now let me zoom in a bit here and hit send. Now let's watch the logs. Let's watch the logs very closely. Okay? So we got to get to our latest run here. Just give me a second. That's the PCAP question. We just got to catch up in the logs. I'm sorry, I should have done this ahead of time. So that's the original question, the first run that we did through the curl. And now we've uploaded the PCAP, we've passed it the question, and you can see here the number of requested results is greater, the index of 26. So there's 26 vectors in the vector store. We can see that the AI has detected a public IP address, and it's extracted that public IP address and gone ahead to the weather API tool to fetch the geolocation. And we get this geolocation back from that tool. Right? Pretty cool, right? Now it would make sense that Google is in Toronto since I'm in Ottawa, and that's probably the closest pop, right? So now we're actually running some NS lookups. We have the NS lookup output, a who is, and we have all the who is data. We're looking into BGP information. We're looking for a threat check against a threat intelligence API. We're even doing a curl, and because it will answer the curl, we can get some information out of the curl data. We're going to ping it, and even though it's public, we can ping it. And we're going to trace to it. You can see that it's only 2 hops away or 1 hop away from the container. Then we're going to do a dig, and we get all this great dig information, right? And then we have our structured output, which synthesizes all of that great information. So first of all, Here's the packet capture overview. Okay. The basic information from the PCAP data itself. Okay. And now it's going to give us all of the public analysis against the IP that it found for the public IP. Geolocation, domain lookup, who is, BGP, path performance, security and threat, web and application behavior, and then the conclusion here. Packet involved between a local device interacting with Google's infrastructure. Communication used quick. There's no significant threats. Now, it's funny, it does say it is blacklisted despite a low abuse score. I don't think that's right. That might be a hallucination. We'll have to look closer into the details from the threat intelligence data. Oh, it's whitelisted false. So it actually is blacklisted. Isn't that crazy? Okay, well, that's the intelligence we're getting. Now, what's interesting is I can ask it a follow-up question. What is the source and destination IP? Send. And it's going to come back very fast because it doesn't need to run the tools. It can use the history and the conversational memory to answer follow-up questions. Pretty neat, right? Now, let's look at the tracing for this one. Let me refresh the page here and grab the latest trace. So check this out. So we did detect a public IP here, true, on one of the IPs. So then it's going to grab the geolocation information, and here in our traces, we get all the API data back per tool, right? So that's the geolocation information. That's the NS lookup information. That's the who is information, right? That's the BGP tool lookup. That's the threat check tool. That's the curl tool. The ping tool took 2 seconds because we're waiting for ping to come back. The trace route, the dig, and then finally the synthesized answer. And we can see, we don't need to do that. There's the input and the synthesized data. Pretty cool, right? Now, I might focus more on the PCAP RAG tool output and favor it more because it is truly supposed to be about the packet, not necessarily about the public IP. However, any public IP detected in the packet, why not enhance the information with all the publicly available information we can scrape about that packet, right? So just to kind of recap and to cover, we still have RAG. We still have the Retrieval-Augmented Generation, but it's a standalone tool that our assistant calls. If we detect public IPs, we have a handful of other tools we can call and invoke. We take all of the tool information and create a synthetic answer. It's a simple start, assist, tool, tool, assist, end in the graph. We have the tracing in LangSmith, individual little tools that scale. I might add, I don't know, some other tool that we find that can take a public IP and do stuff with it. Now I just add it to the toolkit in the toolbox. So I think the next thing I'm going to do now that I have this working with its own REST API system is to put an MCP server in front of this. And that's what I'll hopefully be doing next. Stay tuned. Thank you for sticking with me. Please ask me any questions that you have about this. And I do hope to move this to production this week. I'm ironing out some bugs. I want to make sure that it's perfect and rock solid. And then I need to work with my infrastructure team to port this over to replace the current tool. All right, stay tuned.